All right, so these are the last two examples that I didn't do in the previous video, just continuing straight from where I left off, finding extreme on closed interval. And number 33 has an absolute value part of it, and I don't believe we've run into example where we found the derivative of absolute value. And it's going to be equal to u divided by the absolute value of u times u prime. All right, so this is the definition for derivative of absolute value, and that should be in the list of the table of derivatives and integrals. So for this example, for 33, all right, so first find critical numbers. So we need to find the derivative, so y prime. So the derivative of 3 is 0, so it'll be 0, and then minus the derivative, and in this case our function is based off of the variable t, so I'd put d dt of the absolute value of t minus 3. All right, in this case, our u is t minus 3. So the derivative of u prime, would be technically that the derivative of t is 1, and so it'd be 1 plus 0 because the derivative of negative 3 is 0. So u prime is just 1. So y prime going to equal, and we can just ignore the 0 in the beginning, so it'd be minus, and then times u over the absolute value of u. Well, u is t minus 3. And then absolute value of t minus 3. And then times u prime. Well, you want to be real thorough, so u prime is 1, so times 1. All right, so y prime, negative, and then t minus 3 up top, divided by the absolute value of t minus 3. Now for this negative, I could put it up to the numerator. If I were to put it up to the numerator, it'd be negative, and then you apply the negative sign to the whole quantity t minus 3. So I usually put it in parentheses. All right, and that just switches it so it becomes 3 minus t up top. All right, so that's what the derivative is. And this was just a preference thing to go ahead and put the negative up with the numerator. All right, so I need to find critical numbers, and that involves finding any values for which the derivative doesn't exist, or any values for which you get 0 for the derivative. Now, I would say because of the t minus 3 in the denominator, so I'd say no, can't have t be 3, because you get you have 3 minus 3 up top, and then the absolute value of 3 minus 3, but the point is you have the absolute value 0, which is 0 over 0, and that's undefined. So the derivative doesn't exist at t being 3. All right, so and if we were to do the other case, finding any values for which y prime is equal to 0, you would set the derivative equal to 0, and again, the derivative is 3 minus t, so let me just go ahead and write it. That's the derivative if I set this equal to 0. Then you'll see that, okay, if this sort of equals 0, I only need the numerator to be 0, but the denominator to not be 0. And so if I just focus on the numerator, you have 3 minus t equal to 0, you'll see that you'll get t being 3 again. But we already know that was a value for which the derivative doesn't exist. So it's like having, it doesn't add anything to the problem. So we already know. Y prime does not exist for t equals 3. All right, so the critical number is 3. So I need to find what's the y coordinate that goes with the critical number. All right, and I plug it into the original function, and the original function was y equals 3 minus the absolute value of t minus 3. So plugging in the critical number, that's going to be 3 minus the absolute value of 3 minus 3, which we know that's absolute value of 0. So it's 3 minus 0, which is 3. So that means I have the point 3, 3. Now I just need to check the endpoints. So this is going to be some form of 3, 3 is going to be some form of relative extrema. I'm just going to go ahead and box this since we're going to use this at the end for our comparison of the points. So now find the y values that go with the endpoints. And our interval was, let's see, -1 to 5. So if I plug in -1, that's going to be y equals 3 minus the absolute value of -1 minus 3. That's the absolute, so 3 minus the absolute value of -4. And we know absolute value changes a negative number into positive, so that's really 3 then minus +4. So you get -1. All right, so when you plug in -1, the output is -1. Now plugging in 5. That's 3 minus the absolute value of 5 minus 3. That's the absolute value of 2, which is 2. So that's 3 minus 2. You get 1. So that gives us the point 5, 1. All right, so comparing all of these, so we have 3, 3, -1, -1, and 5, 1. Our 3, 3 point that has the highest y coordinate, so this would be the absolute max. And the one that has -1 for the y coordinate, this is going to be absolute min. All right, so that's pretty much it for that one. 3, 3 and -1, -1 are the extrema. Now the last problem is number 39. It's a quick one. So it's y equals 3 cosine x, and we're on the interval 0 to 2 pi. So the derivative of cosine is negative sine, so that's going to recall that derivative of cosine is negative sine x. All right, so that means y prime. Since we have the 3 in front, it's going to be negative 3 sine x. All right, sine function is continuous. There's no asymptotes to the function, so there's no values for which the derivative doesn't exist. So I'd say note, there's no x values for which y prime doesn't exist, because it's sine function and that's a continuous function with no asymptotes. So I just focus on setting the derivative equal to 0 to get any critical numbers. So that's negative 3 sine x equal to 0, and you divide both sides by negative 3. So that means focus on when sine of x is equal to 0. Now keep in mind our closed interval is 0 to 2 pi. Any critical number that we get needs to be between 0 and 2 pi in the open interval. So critical number needs to be inside of the interval. So all right, so when is sine going to be 0? And so sine is 0 when x. So we know if you had the unit circle and you had the points like 0 and then pi and 2 pi, that's when sine is 0. But we only care about the one that lies between 0 and 2 pi. So our only critical number is pi. All right, that's when sine is 0. All right, so now I just find the y coordinate that goes with the critical number. All right, so the original function is y equals 3 cosine x. Now if I plug in pi, it's going to be y equals 3 cosine of pi. And cosine of pi is negative 1, so that's 3 times negative 1. All right, so that makes this have the point pi is the input, and then the output is negative 3. That's the y value. Now I just need to check the endpoints. So I'll go ahead and box that. So that came from the critical number. All right, so we plug in the endpoint 0. So y equals 3 cosine of 0. Well, cosine of 0 is 1, so that's 3 times 1, which is 3. All right, so that gives us the point 0, 3. And then when you plug in 2 pi, you're going to get the same thing, right? Because 2 pi's complete revolution puts you at the same spot as 0. So 3 cosine of 2 pi. That puts you at, so cosine of 2 pi is the same thing as cosine of 0, which is 1. So 3 times 1, which is 3. So then my input was 2 pi, and the output was 3. And notice these both have the same y coordinates. And they're the biggest, larger than negative 3. So these are two absolute maxes. All right, they have the same y coordinate of 3, they just occur at 2 x values. And then this is the absolute min. All right, and that's it for this section.